Good early morning. This is OXDF. Today we're doing day 8 of the 2023 Advent of Code Haunted Wasteland. Basically, I'm going to get this map, this input, and the first line is going to be a long string of L's and R's, and it's just going to tell me in order, do I go left or right? The next, then it's going to be a blank line, and then followed by a bunch of nodes. And in each node, so like when I'm start at AAA, if I go left, I go to BBB. If I go right, I go to CCC. And that's it. So in this case, if I was right, I'm going to go at AAA, I always start at AAA, and I'm always trying to get to ZZZ. And so if I'm at AAA and my first instruction is right, then I'm going to go to CCC. If I'm at CCC, my next instruction is left, I'm going to go to ZZZ. I'm actually done. 2 steps, that's the answer 2. More complicated one down here. Well, not more complicated, actually simpler, but it takes a little longer. Start at A, I go left to BBB. I go left to AAA. I go right to BBB. Now, because I reached the end here, I'd go back around to the first one. So now I'm back at left to AAA, left to BBB, right to ZZZ. So that was 6 steps. It's okay that I loop through. But anyway, we're there. Yeah, so I guess that's it. Let's go check out the puzzle input. We'll use my GenDay script here. This it makes me a little stub and it pulls the input for me. I've described it in previous videos. Let's take a look at the input. The left and right instructions is quite long, which implies they expect us to go a large number of steps before we get there. And then we have a lot of nodes. 732, so 730 nodes. So, all right, I'm not sure what to do with that, but it's a lot. Let's go ahead and start writing. I'm reading my input as lines right now, and that's fine because we know the structure very well. We need to break it into 2 groups, so we're going to do it this way. We're going to say directions, because that's like the lefts and rights. The next one is that empty line. We don't need that. And then we need, let's see, then we need the rest of the lines to be here, and that'll be like nodes, we'll call. And so if we put a star in front of nodes, that will be, so we'll get the first line, the second line, and then a list of all the other lines right here, and that'll work really nicely for us. The other thing I want to do here is just run a map string.strip on that. I think that'll work that way. Let's check that out because we want to make sure we get rid of new lines. So we'll actually test this now. We'll go Python day 8. I need my example data because I don't really want to run on the huge data yet. Just want to see, can I get these 6 nodes into their own thing? Make a thing, ex.text, run here, and then I like to just do, if I just do python-i, it's going to drop me into a terminal at the end. I think that should be an argument. Oh man, okay, so that might not work. We'll do it. The way I definitely know to do it is strip L for L in there. L.strip. A little early in the morning here. Let's see. That looks good. And now if I do like directions, I have my directions. If I do nodes, I've got my nodes. Sweet. All right, next thing we do, we're gonna make a node map. So we'll say node map equals, and we'll just make it a dictionary. Now we can do for node in nodes. I guess I'm just gonna call it line in nodes. And so each line in the nodes is going to be like this. Grab this real quick, we'll put it right here. So we're going to say key is equal to line.split on equals like that. And the other thing, so actually we can just do key targets is equal to that. And now we can do, we'll say node map sub key is equal to targets. I'm going to run strip on this, and now targets is wrapped. I've already stripped off a new line, but I've got parentheses on either side. I want to get rid of those. So if I just pass in parentheses like that, it's going to remove those from either end. And then I can split on comma space, and that'll be my left and right. So that should work fine. We can test that again. Let's do that. So now we can look at node map, and we have A going to BB and CC, B goes to there, etc. So that works nicely. In fact, what if we we're going to do directions equals, I think it's cleaner if I keep these as different things. So we'll say C for C in direction string. And we can just say int C equals, and we want L to be 0. So we'll make this R. And so by this, I think, we'll always check and verify here. But now if we do directions, 1 and 0, directions string. So now we have R is going to be 1 and L is going to be 0. So now when we come down here, we've saved in here a list, and the first thing is always the left and the second one's always the right. So now we can just do that. We'll be able to use that later. Okay, so now what are we going to do? We're going to say steps. Actually, we'll say part 1 equals 0. We'll say while, we'll say current position equals, well, we started AAA. And so we can say while position is not equal to VZZ. What are we going to do? We're going to say position equals node map of position of part 1. Nope. What do we need here? We need to get the direction, right? Let's make this a little bit clearer. So we'll say dir equals directions sub part 1. That's our number of steps. And now we have to be ready to go wrap around. So we just need to do mod len, let's do len dirs equals len directions. Just so I don't have to calculate that over and over again. And then we can just do len dirs. So basically that's going to allow us to wrap around, because now if our thing is too long, it means we need 0, 1, 0, 1, 0, 1. So this will be, if this becomes 2, 2 mod 2 is 0, then 3 mod 2 is 1, and we just, etc. So that'll work fine for us. And so now we can just do dir like that. And I think we might be done. Try it. Whoa, oh wait, it is important that whenever you run a while loop, you have to increment your counter, or you just run infinitely. Let's try that again. So we got 2 for the example. That was expected. We can do this other example real quick. Save. We got 6. That's looking good. I'm going to get rid of this dash I because it's not doing me anything anymore. Oops. Ooh, early. Trying to get these things done quickly. Let's see. 21,251. Big number, as we kind of expected. We got it. Okay, I'm gonna go read part 2. I'll be back in a moment. Okay. So, in the part 2, instead of going from AAA to ZZZ, we now have ghosts. I don't know why ghosts, but we have ghosts. We're gonna look at there's a ghost at every one that starts at A. At step 0, there's a ghost at each one ending in A. So here we have 1,1A and 2,2A. And then we are going to move until all the ghosts are on one ending in Z. So basically, there's an interesting note here. Because of the way at each space, there's 2 ways we can go, right? And once you hit a space the second time, you're basically going to be, you're definitely going to be in a loop. Now, this loop could go a while, but like, you know, you have to hit a loop. It's possible you only hit the loop and always go the same direction if that's the way the input has you set. But you definitely, once you get going the other way, you're always going to be looping around. It's not clear you always have to go back to the start. Your path could go for a while and then hit into a loop, you know, starting here, going, and then hitting. But you're definitely going to end up in loops. And so we're going to have to do these loops until we end up with all of them there. Given the number, so first, the first question we want to ask, I guess, and I haven't even looked, let's check this, is how many of these things end in A? And so we have 700 lines. Let's do a grep of start.a on input.text. And it looks like we have 6. And let's look at the Z. And it looks like we have 6 as well. That's good. They're not like in the example where we can match which one goes to which one. Interestingly, ZZZ not show up? Oh yeah, ZZZ right there. Okay. So there's 6 of them. So 6 is not that many, but if you look at the size, we went 21,000 steps before we got there once. So let's look at, the next question would be, how many steps does it take our initial run to get there a second time? How I'm gonna go ahead and we're gonna duplicate this. Let's see. Copy day 8 because I want to use this to play around with a little bit. So play.py, and in play.py I want to say okay zzz count equals 0. Say while zzz count less than 10 if position equals zzz, oops, need two equals, then we are going to print that, what did I count? Part 1. Part 1 is no longer a very good answer, but we'll go with it for now. So if I run this and I run Python lay input, whoa, what did I do right? I should only see 10 prints here. Oh, zzz count plus equal. I made the exact same mistake. While loops are bad, man. All right. So what do we got here? I guess the cool thing we can see right away is it looks like it's doubling. Is that exactly doubling? Yeah, it is. So it's this one, at least this node is hitting. It's a straight up loop. So we go from 21,000 to 42,000. We're adding 21,000 each time. Okay, that is useful to know. Let's look at another. Let's grab another one of our. Here, where's our? Shoot. Let's just start at VNA instead. And oh wait, we went A to any. Hold on. Let's play again. But this time we're going to do if position dot ends with, because we're not just looking for zzz, we're looking for any z. So that might change our answer. It did not. Interesting. I wonder if it only ever hits zzz, if it hits any other part 1 comma position. So this one only hits zzz. So where's our grep? Let's start at VNA instead. And we only go to KTZ. And interestingly, I think we're going, let's do this, zzz, we'll call this z's equals that, while len z's, and we'll do z's dot append position. And here we're going to append zz's like this. Oh, that's not what I want. I want, we want append part 1. I really got to change that name. And so now we can do zzz and what I'm trying to do is figure out, like, is this exactly what's the difference here? So we can do, I don't need all of them. I just need part 1 minus zzz minus 1. So I got the last one there. So that should give me the difference, right? Oops, that's not. Oh, because it doesn't exist on the first one. Cheat and add 0 in here just because it helps me with the math. So look, it is taking that exact number of steps every time. Let's just make sure we do this, because we can make some really nice assumptions if we DPA, if we know this. DPA. And yep, it's okay. This can't be coincidence. Like this has to be the fact that this is coming this way has to be on purpose. So let's assume that's going to work for now. I guess, you know what, we check 3. Let's check the other 3 real quick so we can do this. We JPA, DBA are the next 2. JPA. Yes. DBA. Ooh, I don't want to, let's see, undo. JPA there. Should change the one we're changing. That is correct. DPA. That looks fine. And there was one more. There's better ways to do this for sure, but now since we're only 6 and we're already there, like programming them feels unnecessary. Okay, so we know all 6 of them start, and take the same number of steps every time to get there. So that's interesting. Okay, that makes this much easier to solve. Let's do this. So basically what we need to do is for each one of these, we need to capture the cycle time. So we're going to say position equals, so we need to get the starting position. So we need to, let's see, the starting positions will come from the nodes, so we need to go over the nodes. I guess we can do startings equals that. And then here, while we're looping over the lines, if line, let's see, if key dot ends with a, startings dot append key. Now we'll have a list of the keys. And now we will see, we should make this into a function. Let's come up here and we will do def get steps of start, and we'll say steps equals 0. Like the direct lessons, I'm actually just going to move this to here. We can reference it still. Position equals start. We don't position equals start. And then we can do while position is not equals ECC. Steps plus equals 1. Oops. Plus equals 1. And then we just return steps. So by this, I know, but I've changed this around a little bit. Now all we should need to do down here is say part 1 equals get steps on AAA. See if that works. Perfect. Got my same. I don't know why I'm printing. What am I printing? Did I run play? Yeah, really, this is the downside to having two day8.py. Part 1 is not defined because we don't need part 1 here. We need steps. And we got our 21,251. Was that correct? Let's just make sure. 21,251. Okay. So now we feel comfortable. We got a function that can calculate our steps. So now we just need to do, for part 2, we need to do res 4. Let's see. This is actually not going to be hard. Okay, so let's say res counts, step counts. Step counts equals, we're going to do start for start in startings. And for each of those, we're just going to pass call get steps like that. And so that should give us a list of things. Let's do part 2 equals step counts and run this. Ooh, it's taking longer than I would have hoped. I bet you we did not update the starting position. Dot ends with z. That would have stuck us in an infinite loop for sure. And if so, right now it's stopping at 0 every time because position dot not position ends with z. Let's try that. There we go. We got some awesome startings. I would expect 2151 to be in there. Perfect. So now I believe we can so we know the time it takes for each of them to reach. And we know that they're going to reach on those things. So basically, we just need the least common multiple of all of these things, and that'll be it. One solution for sure will be these all multiplied together, but there's almost surely going to be a lower one. So we will do import math. And I believe we can make it as simple as math.lcm of step counts. And so we can try this. We get a huge answer. There's no way we could have run this by brute force. But we got it right. So basically, once we know the cycle time for each of them, the time that they're all going to line up together is the least common multiple. If there was some offset on the cycle time, which would have made this challenge harder, like if instead of going 10, if the first one's cycle time was 15. Instead of going 15, 30, 45, etc., let's say it had been 17, 32, 47, right? So there was 2 steps before he got into the cycle. We could have adjusted for that and calculated that out, but we didn't need to here because they were all on perfect cycles. So that was fun. Not like complicated, but not too hard. I'm glad. I don't know if it's progress that I'm making, getting better at this, or if this one just jumped out, but I'm not sure I would have just gone straight to, I think I would have spent a lot of time trying to brute force this in past years, especially many, 5 years ago when I first started doing this. How long have I been doing this? However long, it doesn't matter. So being able to recognize that challenge and sort of play with the data there was really useful. So call it here. Thanks for hanging out with me today. I will talk to you tomorrow.